So our topic for today is a new topic which is different from all the previous topics, and this topic is known as first order difference equations. What is a first order difference equation? It is a difference equation which is a difference equation is an equation which expresses a relationship between a dependent variable and a lagged independent variable which changes at discrete intervals of time. Up till now, we were studying the like functions where we would say that quantity demand is equal to is the function of prices. Okay, this was a simple equation which we studied previously in all our mathematical economics topics, and mostly we study such kind of equations in different branches of economics. But when we come towards this difference equation, then it is a different phenomena from this one. That is, over here, what will happen is that we will say that the quantity demand is the function of the prices in the previous prices. That is, the people will base their demand in the current time period based on the prices in the previous time period. So therefore, this is now a difference equation where this dependent variable is depending upon the independent variable having a lagged value. That is, the demand is depending on the prices of the previous year prices. Okay. Again, we have different other examples over here. So therefore, this is not a okay. Now this one is not a difference equation, whereas this one is a difference equation. You should know what is the difference between a difference equation and a simple equation. This is a simple equation, this is a difference equation. So therefore, we will be studying such kind of equations in today's topic. Suppose we have an example where the investment of a country, it is the function of income of the country, okay, in the previous year. That is, the investment depends on the income of the country in the previous year. Now, what does this mean? If more income was generated in the year 2020, then the country or the economy will be able to invest more money in the year 2021. If less income was generated in the year 2020, then the country will not be able to invest more in 2021. So therefore, this IT is the function of YT minus 1. It is the economic example of difference equation where I and Y have been measured at the time of each year. Okay, this is measured at the current time period. This is measured at the previous time period. Okay, now this is T, which means the current time period. T minus 1 means the previous time period. Okay. Now to measure the discrete changes, what happens is that we have to take the difference equations, okay? What happens over here is that now we have got the idea what is a difference equation. And again, in the definition, we have that the dependent variable is a function of a lagged independent variable, okay? And that lagged independent variable changes at discrete time intervals. So therefore, if it changes at discrete time intervals, therefore, for this, we should have a difference equation. Now, let us understand this concept more. Okay, let me come here and we'll keep this definition with us at the moment. Suppose we have a function where y t plus 1, okay, that is the income in the coming year, in the year 2022 plus 3yt, income in the current year, that is the year 2021, okay, is equal to 20. Now, what kind of difference equation is this one? So over here we have yt plus 1. Now you have to take care of these years which have taken, okay, and this t. So this is first order difference equation, clear? Now, due to this t plus 1, we will say that this is first order difference equation. Suppose we have another equation where we have y t plus 2, okay. Now we have y t plus 2 over here, plus 6 y t plus 1. 6y, okay, t plus 1 plus 10yt, okay, plus 10yt is equal to, let's say it is equal to 12. Okay. Now this yt plus 2 is showing us that this is second order difference equation. So therefore t plus 1 means that it is first order first order difference equation. This one is the, due to this 2, it is second order difference equation. Okay. Suppose again we have another like this, we will have, if we add a yt plus 3 into it, that is, suppose we have yt plus 3, okay, plus, suppose we have 2yt plus 2 and this equation, then this will become a third order difference equation. The higher the time period with which we are moving, or the lag with which we are moving, that the highest lag will give us the number of the, or the order of the difference equation. Again, we have another form of writing difference equations as well. That is, suppose we have QS is equal to, that is, quantity supplied is equal to A plus BP minus 1, okay? A plus B, P, okay? And with P we have T minus 1. Now again, this is the first order difference equation. Why? Because it is lagged by one time period. Okay, this is also first order difference equation. So you should have an idea that what is first order difference equation and what is second order difference equation. Again, we have another function. This is the last example in order to clarify it further for you. Suppose we have IT is equal to investment in the current time period. Okay, this is equal to A, okay, into Y minus YT minus 2. Okay, YT minus YT minus 2. Now, what is this implying is that it is the second order difference equation. So therefore, the highest lag will determine the order of the difference equation. So the equation can be of any type, depending upon the economic examples, economic variables that we are studying, and of course the type of problem that we are studying. Now what we do is that this is the introductory concept of the first order difference equations. Now we will move on towards our topic, which is termed as first order linear difference equation, and we will solve that and study it. So that now this is first order difference equation in general. What we will do is that now we will study the first order linear difference equation. What is a first order linear difference equation? We know very well that when the power of the function is equal to the highest power of the function is equal to 1, then that is referred to as the linear equation. So therefore, first order linear difference equation will be an equation where the highest power of the variable is equal to 1. That is, there is no square or cube on, there's no power of square or cube on these values. So therefore, first order linear difference equation can be of the form yt plus 1. Okay. So the power of this should be equal to 1. And it is first order. When we say linear, then the power should be equal to 1. When we say difference, the first order linear, difference means that the lag should also be, the highest lag should also be equal to 1 because it is first order linear difference equation. Okay, then we have yt plus 1 plus mu yt, okay, is equal to w. So this can be one of the forms of the first order linear difference equations. This is the first order linear difference equation. We will study this in detail now and explain or study it with different properties of the given function so that it becomes easily understandable to us. So keep in mind this equation. Now we will move on towards explaining this equation. Okay, so this is first order linear difference equation. Now what are mu and w? Okay, let me just do one more thing over here. Let's write it properly with it, okay? This is mu yt. So this is first order linear difference equation. Now what are mu and w? Both mu and w are constants or variable. That is, they can be either constants or variables. It's not necessary that they are constants always. It is not necessary that they are variable always. It depends upon the kind of situation that we are studying. So therefore, they can be, you can say that they can be constants or variables. Okay. Okay. Because they are the functions of time period t. So therefore, first order properties of first order linear differential equations. What we will do is that we will study the properties of first order linear differential equations. For that, we have to explain a few concepts, a few terms, so that it becomes understandable to you. Okay, now move on towards the properties. So now the first property is the first order linear difference equation. I will write it like this. First, okay, order linear difference equation, okay, OLDE. First order linear difference equation is furnished with lag of one time period. Okay, there is lag of one time period. That can be t plus 1 or it can be t minus 1. The basic property is that it has a lag of only one time period. Why? Because we are concerned with the first order linear difference equation. The second property is that the dependent variable occurs in the expression of first degree. The dependent variable that we are studying, its highest power should be equal to 1. Okay, dependent variables highest power is equal to 1. That is, if the highest power is greater than 1, then it will not remain the first order linear differential equation. Okay. So therefore, the dependent variable should occur with the highest power equal to 1. Okay. This is not O, this is T. Okay. Now what is the third property? It is always raised to power 1 and does not occur in terms of the products. So therefore, we can say that if there is this kind of situation where we have yt multiplied by yt plus 1, this kind of situation will never exist, okay? Because it is always raised to the power 1 and therefore it does not occur in terms of the product such as yt into yt plus 1. This is a this condition should not occur in this case. Okay. What next we have is that variables or the constants like mu and w may be linear or non-linear. That is mu and w. Their powers can be higher, powers can be greater than 1. Okay. They can be greater than 1. It is not necessary that they are always greater than 1. They can be equal to 1. They can be greater than 1. So therefore, these are the important properties of the first order linear difference equation. That is, the lag should be of one value only. It cannot be greater than one time period. That is, it can be t plus 1 or t minus 1, the highest lag. Okay. The dependent variable's highest power should be equal to 1. It cannot be greater than 1 or it should not be less than 1 as well. Then the situation where the product yt into yt plus 1 occurs, this should not be the case with first order linear differential equation. So therefore, this is not the case of first order linear differential equation. Otherwise, it will yield us wrong results and we do not need them. And mu and w, they both can be Okay, let me write it a bit. Well, mu and W power can be greater than 1. Okay, their powers can be greater than 1 or their powers can be equal to 1 as well. Now let us solve the question for this. Suppose we have yt plus 1. Okay, these are a few examples first. We have yt plus 1 plus yt is equal to 9. Suppose this is one of the questions that we are given. Now here what happens is that the value of mu, we have nothing over here. So therefore the value of mu is equal to 1 over here, and this is the value of W. Okay? And then we have, suppose we have another example where we have yt plus 1, okay, plus t squared yt. Then we have t squared yt, and this whole is equal to 7t. Now what happens over here is that the value of mu is t squared. Now if the value of mu is t squared, it means that there's no problem with it, because the value of mu or W can be non-linear or they can be linear. Over here, they are linear, the highest powers are equal to 1. Over here, they are non-linear, but still they are the first order linear difference equations. Why? Because the highest drag in both the functions is equal to 1, and the dependent variable has the power equal to 1. There's the power of these functions is also equal to 1. That is that it is not greater than 1. Okay. The power of this mu and W, that can be greater than 1, and therefore it cannot affect our values or function. So therefore, now let's move forward, and to avoid any ambiguity or to avoid any kind of confusion, what we do is that we add a time subscript to y and define the first difference equation, okay, more specifically. Let us suppose that we have, now we will move towards the solution of this particular type of equation, that is the first order linear difference equation. Now suppose we have the given type of function where, suppose we have yt plus 1, okay, minus yt. What does this mean? That the values of the variable in the lag time period, okay, minus the values of the variable in the current time period, this is now equal to delta, okay, delta yt. Clear? What is delta yt? When we take the difference of the lag time period values and the current time period values, then we get delta yt. Therefore, what is this yt? Yt is the value find the current time period, yt plus 1 is the value find period immediately following this time period. That is, if this is 2020, then t plus 1 will be 2021, because it is immediately following the year 2020. So therefore, this is delta yt. Suppose we have delta, suppose we say that the value of delta yt is equal to 2. That's what we do. Then what will we do is that we will substitute the value of 2 over here, and we will get yt plus 1 minus yt is equal to 2. Okay, simply we will substitute its value and get the solution for it. Therefore, yt plus 1 minus yt is equal to 2 for the supposed value of delta yt. Now, how to solve the first order linear difference equations? We will move towards the possibility of the solutions of these equations, because they are different from the differential equations. So therefore, now we will move towards the solution of the first order linear difference equations. Now we will understand how to solve the first order difference equations. And differential equations, our objective was to find the time path. What did we do in the differential equation? Our basic or most important goal was to find the time path. This was something which we did not knew, and we found this out, okay? Now, the time path that we seek in from the difference equation is similar in nature, okay? But it should be function of t minus a. Now, what we will do is that the time path in this first order difference equation is similar in nature, but it should be something like this, t minus a or yt plus a. Now, the value of a can be 1, 2, 3, 4, 5, 6, or anything till n. We know that again, n is some countable number. Now, therefore, defining values of y would be in every time period, which is consistent with the difference equation as well as its initial condition. Now, what we do next is we write down the general formula for this. That is for the, in order to find out the first order difference equation. So, next is, okay, let me write it over here. Now we have to write the general formula. Okay. So now what is the general formula? It is yt plus 1 plus ayt. There is always a general formula for our equations. And then on the basis of these general formulas, we have our economic examples as well. Economic and mathematical examples both. So therefore, yt plus 1 plus ayt is equal to c. Now, what do we understand by yt plus 1? Yt plus 1 is the yt plus 1 shows that it is the first order difference equation. Wait. Okay, wait. So therefore, this is yt plus 1, okay? Then we have a, which is a coefficient. And then we have c, which is a term, okay? Both a and c are two different constants. Their value are 0 or non-zero. That depends upon the kind of situation that we are studying. Now, if we are studying the homogeneous first order linear difference equation, now this is the general form of the equation for the first order difference equation. Now, when we want to move towards the first order linear difference equation, then what happens is that here the difference equation is of the form yt plus 1, okay? Now, this is the first order linear difference equation plus ayt. Now, an important thing over here, if we take this c equal to 0, okay? If we take the value of c equal to 0, then what will it become? It will become homogeneous. I hope you remember the homogeneous and non-homogeneous cases. We will have the same homogeneous and non-homogeneous cases in these kind of equations as well. So this will become the homogeneous first order linear difference equation. Okay, now this has become first homogeneous first order linear difference equation if the value of c is equal to 0. If the value of c is not equal to 0, then it will not be homogeneous first order linear difference equation. Clear? So therefore, solution of this equation will now become equal to yt is equal to, or let me write solution over here, okay? Let me give this blue pen. So the solution of this equation, that is solution is T-I-N. Okay. Now the solution of this equation will be yt is equal to a. Okay, wait. It will be a into minus a raised to power t. Minus a raised to power the 4t, okay? Now, what is this implying? This is the general solution, basically. from where have we got this a into minus a raised to power t? I hope you remember these solutions that we derived earlier in this course, and you will find those lectures in my YouTube videos as well for the first order linear differential equations, where we got yt is equal to ab raised to power t. Now this b is will become minus ab raised to power t. Now this b and this minus a has been derived through similar procedures. Clear? And when we will have, suppose we have yt plus 1, okay? Yt plus 1. Then our solution will be a b raised to power t plus 1. Right? So then it will become, then the power of minus a will be equal to t plus 1. So therefore, we get the general solution yt is equal to a into minus a raised to power t. If we put now, what is this minus a? This minus a has been derived from here, okay? The negative value of this value will come over here, a into minus a raised to power t. So if we put now t equal to 0, now let t is equal to 0. Now let t is equal to 0. What will happen then is, then we will have y of 0. Okay, let me just tell you, simplify or clarify one more thing to you. This t is equal to 0 is for this function, okay? Now, let t is equal to 0, then y of 0 is equal to a, okay, into minus a raised to power 0. And when a into minus a raised to power 0, then what will we get is that we will get y of 0 is equal to a, okay? Then y of 0 is equal to a, and then if we put this y of 0 is equal to a, that is in place of y of 0, we substitute the value of a. What will we get is that yt, our general solution was yt. I'm writing this general solution again, okay? Now yt is equal to, what is the value of a? It is y of 0, okay? So therefore, in place of a, we will write y of 0. That is, yt is equal to y of 0 into minus a raised to power t. What is this implying is that the value of y in the current time period is equal to the value of y in some initial time period into minus a raised to power t. Now for this, we will move towards an example. Okay, this was simple derivation. If we find out, or if we solve this through an example, then it will be further clarified to us. That is, suppose we have yt plus 1. Okay, we have yt plus 1. Okay, yt plus 1 plus 5yt plus 5yt is equal to 0. Okay, yt plus 1 plus 5yt is equal to 0. What happens is that we know, now this thing should be clarified to you, that the value of yt is equal to, this should be clear to you, yt is equal to a, okay, into minus a, this is the value of minus a, that is, we will get a into minus 5 raised to power t, okay? Yt is equal to a into minus 5 raised to power t, and then again, if we put this t equal to 0, if we put the value of t equal to 0, what will we get is that y of 0 is equal to, because this is also the same t, y of 0 is equal to a into minus 5 raised to power 0 will become equal to 1. And therefore, in place of this a, if now we put y of 0, then we will get y of t is equal to y of 0. Okay, this y of 0 has come from here. Okay, y of t is equal to y of 0 into minus 5 raised to power t. If we know the value of t, substitute that also into it, and then we can get a proper solution for this. So this is for the homogeneous case. Now, what if we have a non-homogeneous case? It is very simple. For non-homogeneous case, we will have a simple solution, that is, in that case, we will have yt. Suppose we have yt plus 1, okay? Yt plus 1, okay, wait. Let me write it a bit clearly. Yt plus 1 plus ayt is equal to c. So therefore, in this case, the value of c will not be 0. It will become c. Let me draw a line over here. Okay. Now this is homogeneous case. Now this one is a non-homogeneous case. What do we do in the non-homogeneous case? In the non-homogeneous case, the value of c should not be equal to 0. This c is not equal to 0. Okay. In homogeneous case, the value of c is equal to 0. So therefore, yt plus 1 plus ayt is equal to c. And therefore, in the non-homogeneous case, we will have a different solution. That is, what we get over here is, now let's solve this. So now we have this non-homogeneous case where yt plus 1 plus ayt is equal to c, and therefore c is not equal to 0 over here in this case. Now let's change our thing. So what happens over here is that we will have two solutions. One is the complementary solution, and the other one should be particular integral, as we very well remember. And I have the solutions for homogeneous and non-homogeneous case in terms of differential equations. Kindly revise them so that you understand these functions very well. So therefore, yt plus 1 plus ayt is equal to c. And therefore, what we will do is that first of all, we will find the yc complementary solution. So yc is equal to the same solution, that is a into minus a raised to power t. Okay, no such difference over here because complementary solution is basically the general solution of the homogeneous case as well. But what we have, the next one is we should have yp as well over here. That is, we have yp is equal to this value of c, which is not equal to 0, c divided by 1 plus this value of a. Okay. Now this is the particular integral for the non-homogeneous case. Therefore, what happens over here is that we will have our general solution as yt is equal to yc plus yp. Okay. yc plus yp, and therefore we will substitute the values of yc and yp. We know that the value of yc is equal to yt is equal to, now the value of yc is equal to a into minus a raised to power t. Okay, this is, let me write it a bit clearly. This is a. Yeah. A into minus a raised to power t. Okay. Write it a bit, yeah. A into minus a raised to power t. Then we have plus the value of yp is equal to c over 1 plus a. Now, what is this? This is the value of yc. And what is this? This is the value of yp. Clear? Now, let's again put t is equal to 0, which we generally do in order to find out the solutions for the given equations. Now, if t is equal to 0, what will it mean? It means that wherever we have t in the solution, we will put that equal to 0. Therefore, y of 0 is equal to, therefore, y of 0 is equal to a into minus a raised to power 0, clear? Now this term, clear? Plus, we do not have any t over here, so therefore this will remain the same, that is c over 1 plus a. Now this a raised to minus a raised to power 0, this will become equal to 1. Therefore, what happens next is that then we will have y of 0, okay? Y of 0 will become a, capital A, the arbitrary constant, plus c upon 1 plus a. Now we can find out the value of a from this whole equation. That is, we will let capital A over here and we will shift c over 1 plus a towards the left hand side. Therefore, what will we get is we will get y of 0 minus c over 1 plus a is equal to a. Now this is the y of 0 minus c upon 1 plus a is equal to a. Now what would we do is that we will substitute this value of a, that is y of 0 minus c over 1 plus a, into this particular equation. That is, we will get, what will we get is that we will get, okay, let me just, now what will be our next step? We will substitute this value of a into this equation. Why? Because it will give us, or it will lead us to the general solution. And in the general solution, we will substitute the value of a. Therefore, by looking at this equation, okay, clear? And by putting this value of a into this equation, what will we get is that we will get yt is equal to, what is the value of a? Value of a is y of 0 minus c over 1 plus a. Okay, c over 1 plus a. Where again close this bracket. Then what we have over here is minus a raised to power t. Write it as it is. Plus c over 1 plus a. C over 1 plus a. We knew that this is the general solution. Okay, this is the general solution. But when we substituted the value of a by taking t is equal to 0, we got this value of a. What we will get? We will get the definite solution. So therefore, now this is the definite solution. Okay, wait. Now this is the definite solution. Okay. After finding out this definite solution, what happens next is that what we can do, we will substitute the values of t, a, c in if they are given in our questions, and then we can simply find out the value of yt. For that, I will give you an example that we will solve. I would request you to solve it first by yourself, and then if you could not solve it, then please, then you can have a look at the given video. Now we will solve a question over here. Now we had the general form as yt plus 1 plus a yt is equal to c. Suppose we have a question where it is of such kind that y t plus 1, okay, yt plus 1 minus 3 yt is equal to 7. So now yt plus 1 minus 3 yt is equal to 7. And also what we are given over here is that y of 0 is equal to 9. This is something that is given. But there are two other values that are known from this particular question. That is the value of a is equal to minus 3. Okay, it is already minus 3. And the value of c is equal to 7. The value of c is equal to 7 indicates that this is the case of non-linear homogeneous difference equation. Okay, when it is not equal to 0, it means that it is the case of non-linear homogeneous difference equation. Now, we know that the general solution over here is Now the general solution over here is equal to yt is equal to yt is equal to a into minus a raised to power t. Okay. Now general solution is yt is equal to a into minus a raised to power t plus c upon 1 plus a. All we can do over here is that simply substitute the values. C over 1 plus a. What we want to do over here is that we will substitute the values. Therefore, yt will become equal to yt is equal to okay a into, we know that the value of a is minus 3, so therefore minus into minus will become plus. Therefore, what will we get is that we will get 3 raised to power t. If we have the value of a equal to plus 3, then over here we will get minus 3. If the value of a is equal to minus 3, then we will get plus 3 over here, okay? 8 3 raised to power t plus, then what will we get over here is that 7 divided by 1. Over here we have to write the same value. Why? Because here the sign is positive, so therefore it is minus 3, we will write minus 3. If it is plus 3, we will write plus 3. Okay, now yt is equal to what will we get next is that yt is equal to a into 3 raised to power t plus 7 upon 4. Plus 7 over minus 2. Because 1 minus 3 is equal to minus 2. Now, how can we definitize this general solution? This is basically the general solution. All we need to do over here is that we have to definitize this general solution. In order to definitize the general solution, we will take this t is equal to 0 and this t is equal to 0. Therefore, let me write it over here, or let me just move forward. Now to definitize this general solution, we will take t is equal to 0. Okay. Now by taking t is equal to 0, what we get is that from here, what will we get is that y of 0 is equal to a 3 raised to power 0 plus 7 divided by minus 2, because 1 minus 3 is minus 2, of course. So what will we get next is y of 0 is equal to this 3 of 0 will become equal to 1. Why? Because the power of 3 is 0. Okay, therefore what will we get over here is that a plus 7 divided by minus 2. Okay. Now what will we do next is that we will find out the value of a from this equation. That is, by keeping a over here and shifting 7 raised to 7 divided by minus 2 on the left hand side, we get a is equal to y of 0 minus 7 over minus 2. Clear? So therefore, in the end, what will we get is that we will solve it further. We will get minus minus is plus. So therefore, a is equal to y of 0 plus 7 over 2. Okay. Now, when we started the question, what we got was that we knew that we were given that the value of y of 0 is equal to 9. Okay. This value of y of 0 is equal to 9. This is given in the question. So therefore, a is equal to, you can simply substitute it over here, 9 plus 7 upon 2. Now all that you need to do is that you have to solve it completely from here. Therefore, 9, we have 1 over here, 1, 2 are 2. So therefore, A is equal to, we will take an LCM, okay? If we want to get a 2 over here, we'll multiply this with 2 and we'll multiply this also with 2. We will get the value of A to be equal to 18 plus 7 divided by 2, okay? 19, 20, and it will become equal to 25 by 2. Okay. So simply what we do now over here is that we have got the value of A as well. And in order to definitize our solution, that is general solution, we will substitute this value of A into our general solution and we can get the definite solution in a very simplest way. Therefore, now our next step is to substitute the value of A, the value of A which was equal to, okay, there's some issue in this pen to start writing. Yeah, it was started here. Now I just want to go down just for once again, so that now the value of A is 25 by 2. We have to keep this in mind. This 25 by 2. And this is the general solution. That is y t is equal to A raised into 3 raised to power t plus 7 upon minus 2. We know that the value of A is 25 by 2. And in order to definitize this general solution, what we will do is that we will substitute the value of A into this general solution. Therefore, the value of yt is equal to, we will have a bracket 25 by 2, okay, into 3 raised to power t, because 3 has the power of t, so therefore this 3 will never be multiplied with 25 over 2 unless and until we know the value of t, plus 7 over minus, plus 7 over minus 2. So therefore our question has been solved up till here, and this is the solution that we needed. This t is the completed same solution. It's complete over here. After this, we will move towards the dynamic stability of equilibrium. And in order to understand the dynamic stability of equilibrium, you will have to go through this lecture very importantly. Thank you very much. Thank you. If there are any questions, you can ask me anytime. I'll be available. Thank you.